Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 6th May 2023. The problem statement for today is another coin change problem. Let's now open this problem to solve it. Let's go through and understand the given problem statement. Here it says, given three integers n, kit and target and an array of coin of size n, find if it is possible to make change of target cents by using the infinite supply of each coin, but the total number of coin must be exactly equal to k. Okay, so the problem statement is asking us to determine if it is possible to make exact change of a certain amount which is given as target using a given set of coins of various denominations while using exactly k coins from the given set. We are given n, the number of coins in the set, and the array coins representing the denomination of each coin. The function returns true if it is possible to make change for the target amount using at most k coins from the coin array, and it will return false otherwise. Okay, so I hope the problem statement is clear. So let's go through the given examples to understand it in a better way. So the first example says, here n is equal to 5, k is equal to 3 and target is 11. So the first problem statement or the first example, it is asking us to make 11 using at max 3 coins from this coin array which is containing 5 denominations. Okay, so here the output is 1, that means it is possible to make that. So what is the explanation for that? 2 coins of 5 and 1 coin of 1 can be used to make a change of 11. So here, since our target was 11 and we had to use exactly three number of coins, so we can use 2 coins of 5 and 1 coin of 1. So it will be, so when we add all of this, so it will be 5 plus 5 plus 1, it will be 11. So yes, it is possible to make the target change. When we go to the second example, so here it is saying n is equal to 3, k is equal to 5 and target is 25. So now we have to make target change of 25 using at max, not at max, using exactly 5 coins. And we have, in this coin array, we have three denominations. That means of 7, 2 and 4. So here also the output is 1. For this also it is possible to make the change. So how exactly we can do that? We can use 3 coins of 7 and 2 coins of 2. So we use 3 coins of 7 and 2 coins of 2, so it will be 21 plus 4, it is 25. So the same is given here, 7 plus 7 plus 7 plus 2 plus 2. Okay, so even for the second example, it is possible to make that. So I hope both the problem statement and the given examples are clear. So for solving this problem, we will be using the approach of dynamic programming. The basic idea is to use one-dimensional array to keep track of all the amounts of change that can be made using up to I coins, where I ranges from 1 to k. That is the maximum number of coins that is allowed to be used. Okay, so with this approach we will be solving this problem. So let's understand it in a better way, the step-by-step sequence of solving this problem. So here I have taken the reference of the first example only, where n was equal to 5, k is equal to 3 and target is equal to 11. So we have to see that whether we are able to reach the target value of 11 using at max 3 coins. Okay, so for this one, since we are using 3 coins, so you can see here this is containing 3 rows, that means 3 iterations. It is not exactly this one, yeah. So this array will be altered thrice, just for each coin at a time. And if you see this one, it is starting from 0 to 11. That means the target element is 11. So here it is saying, and what this is representing? This is representing that in each step, the value that can be reached using those coin set. So I'll explain it just now. So initially, this array, it contained everything as 0. Okay. So when we iterate through this coin for the first time, that means first time means we are using each of the coin only once. Then we see that which all values can be reached. So when we iterate to this one, then we get the value as 1. So we can say that, yeah, value of change of 1 that can be achieved. See, here it is, sorry, just mention, this is with one coin, all the values that can be reached with one coin. This is with two coins, all the values possible with two coins up to the target index, up to the target value. We are not bothered about the values that might come after that. So with three coins, okay. So with one coin, what all value can be reached? We can reach 1, so 1 is made as 1. We can reach 10, so in index 10, that is made as 1. 5, index 5 made as 1, 6 made as 1, and 8, even 8 is made as 1. So this array is indicating that wherever 1 is there, so with one coin that index value can be reached. So that is 1, 5, 6, 8 and 10. Now when we are using two coins, so then let's see then that what all things that what all values can be achieved when we use two coins. So when we use two coins of all these things, then we see we can get the value of 2. That means two coins of 1 will give the value of 2. Okay, we can get the value of 6. So with one coin of 1 and one coin of 5, we'll get the value of 6. We can get the value of 7 as well. One coin of 6 and one coin of 1. This will give the value of 7. Then here we can get the value of 9. One coin of 1 and one coin of 8. That will give the value of 9. Then here we can see that yes, we can get the value of 10. Even we can get the value of 10 by using two coins of 5. So we get the value of 10. Then we get the value of 11 by using one coin of 1 and one coin of 10. So this array contains the value when we are using two coins. But actually the question says that we need to use three coins. So now we will see which all values can be reached when we use three coins. So when we use three coins, so we can reach up to 3 when we use one coin of and that means the 3 coin of 1 will reach 3. When we will use 3 coins, then we can reach 7. 2 coins of 1 and 1 coin of 5. We can even reach 8. 2 coins of 1 and 1 coin of 6. We can reach 10. 2 coin of 1 and 1 coin of 8. We can reach 11. 2 coin of 5 and 1 coin of 11. And 1 coin of 1. So here with 3 coins, it is possible that with 3 coins we can get all the values, that all the index position values, whatever is there with value 1 in this array. So we can reach here 3, we can reach here 7, 8, 10 and 11. So here, since we are getting this array length was 11, because till that only we are bothered, and even the target says it is 11. So we can just see that if that index position, what is the value at that index position of 11? So here it is 1. That means it is possible to get that value with 3 coin. Okay. So this way we will be solving this problem. So this is the dynamic programming approach. So whenever we are getting one solution, we are using that sub problem solution to solving the next step. Similarly, when we get the solution for 2 coins, we are using that value and we will be getting the values which can be reached using 3 coins. Okay, so I hope the problem, this solution is clear. So since this value is 1 and this is the target target index, which is 11, so we are returning yes, we will return true, saying that yes, we can reach the target element with the given denominations in the coin array. Okay, so with this solution I have prepared, with this approach I have prepared one solution. Let me just copy it here. So here, this is the complete solution for this. I have even tried giving comments against each line so that it becomes easy in understanding what all things are done. So here we will be doing exactly the same thing. So what we are doing, here this function is using dynamic programming to solve the problem. It initializes an array that is called ways of length target plus 1 to all zeros. The index I of the array, see this is very important, the index I of the array represents the amount of money that can be made using the coins available, and the value at that index represents whether it is possible to make that amount using the coins available. Okay, so I'll just explain again. So whatever is the index value, index position, what is the index position of this value? Index position here is 11. So that is the target element. That means that is all the values that can be reached using those coins. And here 1 is indicating that yes, it is possible to make that amount using the coins available. So the index represents the amount of money that can be made using the coins available, and the value represents yes, it is possible to make the amount using the coins available if the value is 1. If it is 0, then it is not possible. Okay. So for that reason we will be so we are initializing an array ways to keep track of all the changes that can be made. Okay, then what we do, then this function then loops through the coin array and set the corresponding value in the ways array to 1 for each denomination that is less than or equal to the target amount. So we iterate through that complete array, and whatever the value less than target element, because we are only bothered about up to target element. So for all those values we are making this value as 1. Yeah, we are marking that index position of that particular value in this ways array as 1. So this will be the result when this complete loop will terminated. So the first one, this one will be the output of that one. The ways array will look like the first step, because there we are using for the first one. Then what we are doing, then after that, then the function loops through the remaining number of coins that can be used, that is k minus 1, and for each iteration it creates a new ways array. It loops through the ways array, and for each index that has value 1, here we are checking, for each index that has value 1, it loops through the coin array and adds the current denomination to that index. If the resulting index is less than or equal to the target amount, the corresponding values in the new arrays is set to 1. After the loop completes, the ways array is replaced with the new ways array that we are replacing it here. So whatever the new value which we are getting in new way, this one in this new ways array, that we are setting into the ways array. Okay. After the loop completes, this ways array is replaced with the new ways arrays. Finally, the function returns whether the target amount can be used using the coins available by checking if the value at the target index in the ways array is 1 or not. So here we are checking that here for the first example, here the target was 11. So we are checking whether the value at ways of in this ways array at the index position 11, that is 1 or not. That means if that is possible or not, possible to reach to the target value using the coins available. If that is 1, then it will return true, else it will return false. Okay, so I hope this complete solution is clear. So here so I'll just summarize it again. We are creating an array to keep track of all the value that can be reached using the coins available. So first we are initializing it with the whatever the value which we are given in the input coins array. Then for the next for the remaining k minus 1 iterations, we are using this one. We are creating a new ways array, and we are populating this new ways array using the values of ways array wherever it was 1. Wherever it was 1, then for those elements we add the current position value with that the current position value and the value whichever we have got from base array, and check if it is less than target. If it is less than target, then we can say yes, that this particular index position or the value of the index position can be reached, and we are marking it as 1. Okay. So we are looping through the base array, and for each index that has value of 1, it loops through the coins array and adds each coin denomination to the index. If the resulting index is less than or equal to the target amount, the corresponding values in the new array set is set to 1. Okay. So this was the complete solution. So let me try compiling this code. So here we can see we have got correct output for this given input. Let me try submitting the solution. So here we can see it has passed all the test cases. So this problem has been solved successfully. So talking about the time complexity of this provided solution, it is in the order of n into k into target, where n is the size of the coins array, k is the maximum number of coins that can be used, and target is the target amount for which we want to make change. The initialization loop runs big of n time since it loops through the coins array once. The outer loop runs k minus 1 time, this one, k minus 1 time, and since it loops through the coins array once, the outer loop runs k minus 1 time, and the inner loop loops through all the possible amount up to the target. The innermost loop loops through the coins array, and therefore the time complexity of the two nested loop is in the order of big O of n into k into target. Okay. So this was the time complexity. So this was the solution in Java. I have even prepared C++ solution. Let me move to this editor. The logic is completely same, only the syntactical difference between C++ and Java, whatever we have, so that only is considered here. So here also we are first defining an array or the vector with target plus 1, that's length. Then for the first iteration, we are marking whatever the value of the coins array that has been given, we are marking it as 1. Then for the remaining iterations, we check wherever it is 1, so to that place we add the value of the current change up to, that means current index up to the target value, and we check if it is less than target or not. If it is less than, then we update even that can be reached using the coins in the subsequent iterations. So and once this loop terminates, we assign this new ways to ways again, and finally this, when this entire loop gets over, then we check what is the value at that index position of the target. If it is 1, then we return true, else we return false. So let me try compiling this code. So even with this we have got correct output. Let me try submitting this solution. So here you can see even with C++ solution, it has covered all the test cases. So this problem has been solved successfully in both C++ and Java language. So I'll provide the link for this question and the link for the solution code in Java and C++ in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.